conference.
We're back. Welcome back. We have two amazing speakers for the next half hour, Gianni and Clément. So welcome.
Welcome.
Thank you so much for joining.
Good afternoon, everybody.
It's our pleasure.
Before you start, can you introduce yourself for a bit?
Okay, I'm Clemente Giorio, aka Tino Tinux. I'm a principal senior software engineer in a computer vision company.
Hello, I'm Gianni Rosa Gallina, R&D Technical Lead in the Innovation Lab for Deltatre.
Wow, sounds good. And your session is about generative AI.
Yes, right. We aim to provide you a comprehensive overview, enriched with engaging and practical examples that showcase this technology in a real-world application and potential. So, without further ado, let's dive in and discover the wonders of generative AI.
Sounds good. Looking forward to it. So the floor is yours. Good luck.
Thank you.
Thank you.
So, after our presentation, from Arthur C. Clarke once said, any sufficiently advanced technology is indistinguishable from magic. This statement captures the essence of generative AI. To the observer, the output of generative AI may seem conjured from the thin air, akin of a magician's illusion. Yet it's the result of a complex algorithms interpreting data and learning to mimic the creative process. It's here, in the blend of science and artistry, that we witness the true wizardry of modern technology. In the vast expanse of technological advancement, we find ourselves standing on the shoulders of the giants. This iconic phrase attributed to Isaac Newton encapsulates the essence of generative AI. We are not starting from the scratch, but rather building up on the colossal groundwork laid by pioneering researchers and developers in artificial intelligence. Each algorithm, each line of code, and each model we employ today, it's a testament to the cumulative wisdom passed down through the generation of innovation. The generative AI universe stands on the shoulder of the foundation models, powerful, versatile algorithms trained on diverse and extensive datasets. These models are the engines behind a myriad of applications that span various domains. For example, speech synthesis, producing a natural and expressive synthetic voice, or music composition, composing melodies and harmonies that resonate with human emotions. These models don't just generate, they are the bedrock for further specialized tasks, pushing the boundaries of what AI can achieve. Building upon foundation models, we unlock a suite of capabilities that further demonstrate the magic of generative AI. For example, text-to-speak, text-to-text, text-to-video for crafting a motion picture from storylines, image-to-video, animating style images into video sequences. This application exemplify how generative AI serves as a multipurpose tools, opening up new vistas in human-AI collaboration. Generative AI transcends behind a merely tool. It's a transformative force across industries, enhancing creativity and efficiency. It heralds a new epoch in arts and science, offering a groundbreaking solution and creative breakthrough. With its help, artists are redefining expression, and researchers are accelerating discoveries. These are mere snapshots of generative AI potential to revolutionize our approach to work and creativity, signaling the beginning of a new journey where our imagination is its only boundary. In the realm of the text generation, OpenAI's GPT-4 emerged as a state-of-art AI, transforming human-computer interaction. With the capabilities enhanced by the latest GPT-4 Turbo and extended context with around 128K tokens. This model push the boundaries further of natural language understanding and generation. Integrated with Microsoft Azure as a sophisticated cognitive service, GPT-4 leverages Azure's powerful cloud infrastructure to deliver stable, high-quality, AI-driven text generation services to a broad spectrum of users, from individual developers to large enterprises. DALL-E 3 represents the latest evolution in the text-to-image AI, transforming written description into compiling visuals with an unprecedented accuracy and detail. This model leverages deep learning to interpret and visualize concepts, nuances, and even emotion contained within the text prompts. It's an innovative tool that continues to blur the lines between human artistry and artificial intelligence, opening a new realm of creative possibilities. Building on the momentum of generative AI, Stable Diffusion emerges as a powerful model specialized in content creation. It stands out for its efficiency and versatility in generating high-fidelity images from a textual description, representing a good open-source alternative to DALL-E 3 and other commercial services like Midjourney. Stable Diffusion is designed to democratize the creation process, making it easier and faster for users to bring their imaginative concept to life with a stunning clarity and detail. Runaway take the generative AI scene a step further by offering a text-to-video service. It harnesses the power of AI to convert textual narratives into captivating video sequences. This service is revolutionizing the storytelling, advertising, and content creation by providing an accessible platform where a user can bring emotion to their stories with simple text descriptions. Runaway is at the forefront of emerging linguistic expression with visual dynamism. The generative AI landscape is rapidly evolving, and the latest addition to this innovative field is Stable Video Diffusion by Stability AI. This advancement expands the capabilities of Stable Diffusion in the realm of video, allowing for the creation of dynamic and full motion narratives from text. This represents not just a stride, but a leap in content generation, often offering a nuanced layer of depth and fluidity that complements and enhances services like Runaway's text-to-video offerings. As we continue to explore the vast potential of generative AI, I now pass the torch to Gianni, who will take us deeper into the world of Stable Diffusion. Stay tuned for engaging demonstration that brings our discussion to life. Over to you, Gianni.
Yeah, thank you. Let me share my screen. So, as Clemente introduced us, what is Stable Diffusion? Most of you maybe already know it. Stable Diffusion is a family of models that starts from the text and generate an image, like you can see in these schematics. It goes through a complex pipeline of 3 or 4 models that run within. And starting from the text, we have a tokenizer. We then have a text conditioning unit that embed the information and then start from some random noise, and through a repeated approach, repeated steps, transform the random noise in the desired output images. This is important because we cannot only start from text to image, as you already may have seen from different kind of models and families, but we have the options to go from image to image. So we, in addition to the text, we also can have an image as input, a text as input, and together we can edit images through text. This is important because we see in a moment that is the same approach can be applied to different scenarios, and we go deep dive in the topic of this session. So talk about audio and music generation, but we'll see in a moment. First, just to introduce you, if you've never seen it, there are two main tools that you can use to explore stable diffusion. One is the Automatic 1111, which is an open source solution that is it can enable you to test the state-of-the-art models from the initial one from last year to the most recent one, as well as all the changes. There is a lot of extension that they can use, and you can, for example, do text to image, image to image, perform audio generation, phase swapping, and many other activity and tasks related to stable diffusion and image generation. There is also a different and a lot powerful but more complex interface. It's Config UI, which, as you can see from these screenshots here, it takes a different approach. It is a node, a composable node interface where you have all the components of your pipeline, and you can plug and play topics and connect each different nodes to generate what you want to achieve. So you can have specific text encoder, a specific model. You can split out the samples and also configure the decoder. But we are not talking about this web tool today, as we are mostly .NET developers on Microsoft platform. There's also the option to use a different approach. Models can be converted to Onyx format, and through the Onyx runtime, we can leverage the .NET ecosystem. So I started developing, just for studying and for fun, a very rough project, which is Sharp Diffusion, which is a library that, as you can imagine from the name, can be tend to be porting, a one-to-one porting of a famous library in the Python world, which is diffusers. Of course, it's very limited now, but if you go to this repository, you can, and then we can see a demo, you have a fully functioning application in .NET based on the Valonia. So it can work on either on Linux, Windows, and Mac OS. So let's try to run it, just to have a quick example. So as you can see, is we don't talk about all the data, but you can see it's an Avalonia application with all the dependency injection, view models, view, and so on. And we have the important part here, which are the services, and we have the image generation service. We can configure the model from a configuration file, but you can see we are using the Onyx runtime, which can load now the standard Stable Diffusion models 1.5, as well as the optimized one. You can use some tools like Olive from Microsoft, as well as other tools to optimize the model. So here you can also run the FP16 optimized models. As you can see, it's very, very fast. On this machine, which is on a Titan RTX GPU, it's for 4 years ago a CPU, Intel. As you can run in 10 seconds 4 images. It's and it's all available here. You can see here from the code. It's a CLI application which is simplify how you can integrate these parts in the library in your own application. It's given it's a direct port of the version from Python. You have just to set up some configuration for the CUDA environment. This is specific for the Onyx runtime, so we want to use either CPU or CUDA. You can specify which model you want to use, and then with few lines of code. So for example, this one, you can load the Onyx Stable Diffusion pipeline like you would do in Python, specifying which model to use, set some settings like you have seen also in the interface, define the prompts and the negative prompts, and then with just one line of code, you can run it on your own local machine. You have the output, and also there is the support for the safety checker. So for each image that has been generated, you also have a potential check to detect if the generated content is safe or not for your own purposes. Going back, so you have all the reference here. So Config UI, they're all open source, so you can test it on your own machine. And also there is this repository here with all the description and how you can get started to test your own application. Going back to the slides, we then now shift to a different topic, which is audio. And we start from Refusion. Refusion, I was saying, is an application of stable diffusion concepts, so the diffusion model applied to a different scenario, to audio. As you can see here, we have the same pipeline that we see for stable diffusion to generate images. So we start from a text, there is a tokenizer, an embedder, there is a random noise, and then we have the conditioning unit. What is the output of this kind of scenario? Is that instead of having pictures, photograph, whatever you want as images, we generate spectrogram, which are the visual representation of sounds and music. And then after a post-processing step, an additional step that in images we don't have, we can then go back and reconstruct the audio signal. So for example, if you go to this site here, you can test it on your own. An example is this one.
At the global AI, crafting images, music, and voices with generative AI.
Cool. And you can start just from the text, and this service can generate your background images, the music, the text, and build it up for you. If you don't want to use this service, it's all open source. And now I can leave the word to Tino that will explain how to run on your own machine.
Thank you, Gianni. Stepping into the generative AI space, the efficiency deployment of models is paramount, especially when resources demands are high. Enter OpenVino, an open source toolkit from Intel designed to optimize deep learning models for fast inference on a variety of devices, including those that only have CPU capabilities. OpenVino's ability to streamline and accelerate inference allows for the deployment of complex, resource-intensive generative AI models in an environment where computing power is limited. It's a game changer for bringing advanced AI applications out of the server rooms and into the everyday devices. Completing these is the Neural Network Compression Framework, NNCF, which integrates with OpenVino to provide advanced model compression techniques. And NNCF helps in reducing the model size and computational demands, making it possible to run heavyweight generative models more efficiently without compromising on performance. Get ready to witness this in action as we gear up for a live demo, showcasing the synergy between generative AI and OpenVino. OpenVino notebooks are your gateway to mastering the OpenVino toolkit. These interactive resources are crafted to accelerate your learning curve, offering hands-on experience with a real-world application. Whether you are beginning aiming to understand the basic or an experienced developer looking to optimize AI models for production, OpenVino notebooks provide comprehensive guides to help you every step on the way. Start your journey towards AI excellence with these expertly designed tutorials. Let me show you a demo. Gianni talked about the diffusion model. The way to use this model on OpenVino is very easy. In a nutshell, we specify the model on Hugging Face. We select the hardware to run the model. In this case, the model was inferenced on a CPU, and simply run the pipeline. Of course, as Gianni showed to you, the output of this of a text is an image that should be converted in audio. So when we run the the pipeline, we use as a prompt rock guitar solo with percussion. This is the spectrogram, and this is the output. Considering that it is generated from scratch from a CPU in real time is very, very amazing. Let me show you another interesting project. Music Gen, controllable music generation. Music Gen is a single-stage auto-regressive transformer model capable of generating high-quality music samples conditioned on the text description or audio prompts. The text prompt is passed to the text encoder model, T5, to obtain a sequence of hidden states representations. These hidden states are fed to Music Gen, which predicts discrete audio tokens, audio codecs. Finally, audio tokens are then decoded using an audio compression model and codec to recover the audio waveform. Apart from this architecture, I'm jumping again on the demo. As we can see in the Jupyter, on the OpenVINO notebooks, we have all the description to understand how to use the model. So we downloaded the model from Hugging Face, simply specify to use the CPU, how long should be, and run the pipeline with our prompt. This is the output. Very, very cool. Another interesting model is Audio Gen. Let me show the architecture. So, with this model and with a similar approaches, we generate an audio, a sound, a surrounding sound starting from a text. Now I will show you the demo. So in the same way, it's very, very easy with OpenVINO. The example is the architecture is on the top. So we specify the name of the model. In the same way, we specify the prompt and the negative prompt, like as showed by Gianni for Stable Diffusion. This is the output. Very, very cool. Of course, to show you that everything is running on a CPU, I extract this example. And that's it. It's a generative AI model running on CPU. Okay. Now I give the word to Gianni to talk about speech to text.
Text. It's a different topic, but instead of going from text to generate audio, we go from speech, audio, whatever, and convert back to text. We listen to this example.
This is the Micro Machine, and presenting the most miniature motorcade of Micro Machine. Each one has dramatic details, terrific trim, precision paint jobs, plus incredible Micro Machine pocket playsets. There's a police station, fire station, restaurant, service station, and more.
It's very, very fast, but Whisper from OpenAI is a cool model, open source model, fully complete open source, that enable us to transcribe the text. So going a little bit faster, given short time. What is Whisper? Whisper is a different approach. Start from spectrograms. Then there is an encoder block and a decoder block like in large language models. So we decode tokens. And the idea is that from audio, we are able to generate text. There are various ways to use it, starting from the open source OpenAI official repository, but there are other interesting projects like the Whisper C++ and the Whisper.NET projects that enable us to run locally on our own machines, also the very large models. And in addition to that, apart from having the requirement of GPU, we can also run on CPU only. Like before, I started to exploring Whisper, so I taken I built a simple CLI application that leverage Whisper.NET, and I would like to show you how it works. So the idea is to play this audio. Let me know if you can hear it.
In this workshop, we're flowing through an overview of some generative AI services. In this workshop, we're flowing through an overview of some generative AI services in different scenarios. In a moment, we'll see some alternative open source models.
So this is the audio. We can go in this project here. We can pass it the path to the file and the model that you want to use. So from the very little one to the latest addition is large V3, and then make it running on our own machine, transcribing it very, very fast. As you can see, now I'm using a GPU, but it's possible to use the CPU only as well. And it's already starting. It loads a little bit on the memory. And then we have 20 seconds of audio perfectly transcribed in less than 3 seconds. It's very easy to use. We can pass the parameters to the application. We can download our model if it's not already available on your machine through this sample here. And then model through a factory, we can load it in memory. We open some streams to the audio, and then we have a for each on process and sync. This will take each sentences and transcribe it down. Then you can use whatever you want to process the text and do what you want. Stay on the audio side. Go back to the slides. Stay on the other side. We have also the text-to-speech approach. So we've seen before we can generate audio from text, music from text, but we also can generate speech from text. And in this example, there are 3 commercial offerings. One is the 11 Labs.
In this session, we're talking about generative AI. This sentence is read by an artificial voice from 11 Labs.
Which is very high quality, and as you can see, can support multiple languages with emphasis and other emotion. And then there are APIs from OpenAI with the new text-to-speech APIs, as well as the Microsoft text-to-speech services, which through neural voices are providing very high quality examples. To you, Tino.
Thank you, Gianni. Let me show an open source model that we can use for text-to-speech tasks. As the same way, we can ingest a prompt and the model generate the speech using a pre-trained voice. In this case, using the model is very, very simple. We run all the requirements. In this case, we use a GPU, so the CUDA and NVIDIA accelerator. And we run the pipeline with the parameters. This is the output.
Hey, have you heard about this new text-to-audio model called BARC? Apparently, it's the most realistic and natural-sounding, text-to-audio model out there right now.
It's very incredible. It's interesting also the official documentation and demos that show how to generate a discussion between 2 guys. Let me jump to another topic. We have also as a service audio to audio capabilities. Gianni, could you share an output?
Sure. Here we are. This is the latest demo. So you heard before the audio that we are able to transcribe.
In this workshop, we're flowing through an overview.
Okay. And this was generated from 11 Labs, but we can use any other services. This additional example here, we can load a model here, load an audio file, and make it running. What we'll do, running on the GPU, you should, as you can hear in a moment, will generate, starting from the specific audio, we can convert to another voice. So it's not text to audio, it's audio to audio. And the results are quite good. We experimented with my voice and Clemente's voice. And in a moment, you will see, we will listen to the results.
In this workshop, we're flowing through an overview of some generative AI services in different scenarios. In a moment, we'll see some alternative open source models.
Cool.
This sentence is read by an artificial voice from 11 labs.
This is not true. This is your voice, Tino, right?
Right. It's my voice with another microphone. So the model replicate also the sound of the catched by another mic. We are at the end of this presentation. So, just for fast recap, today's overview provided a comprehensive glimpse into the transformative world of generative AI. We examined the stable diffusion's capability in image synthesis, experienced the integration of OpenVINO with the notebooks for optimized AI workflows, and explored the sonic landscapes of Refusion, music gen, and audio gen in audio generation. We delved in the Whisper's advancement in speech recognition, evaluated the latest in the text-to-speech technologies, and investigated innovative audio-to-audio conversation applications. Each of these components represents a critical piece of a generative AI ecosystem, collectively driving the frontier of AI innovation forward. Let's conclude with a crucial reminder. Ethical AI practices are not negotiable. Prioritizing model security and data privacy is essential to safeguard our advancement and maintaining public trust. As we innovate, we must remain conscientious guardians of the technology we wield. Thank you for your attention and engagement today. It has been a privilege to explore the frontiers of generative AI for you. Your truths and inquiries are invaluable to us. If there are any questions, insights, or clarification you seek, please feel free to share them. Your curiosity drives deeper understanding and innovation. So, what question do you have? In any case, in our slide, we will find all the references and all our contacts.
Fantastic.
Thank
you
you
so much, both of you. That was such a great session. I certainly learned a lot. Here's my quick question for you. It's been really refreshing to hear more about sort of like audio and video, because I feel we hear a lot about sort of text and image sort of, you know, up first and then these things come later. So it's been really nice to see that. Firstly, why have you dove so deep into those spaces? Do you have like ongoing projects with this kind of stuff? Are you seeing demand?
Gianni, hi.
Yeah. As in the innovation lab in Deltatre, as well as Clemente in his company, we are always exploring at 360 degrees what's available, what technologies are available. So throughout the year, we went through all the steps from text to images to video, then to audio. So we explore all the
oh, incredible
possibility.
So, yeah. You are a bit further ahead. So how do you go about finding these different open source models? Like, I'd heard of a couple of them, but a lot of them were quite new and you had like multiple resources. What do you search, or does ChatGPT help you out as well?
Naturally, every day we are looking for the state of arts and the research environment, and sometimes we are trying something and release it a couple of minutes in advance. It's very
with pros and cons. Yeah.
Yes, of course. Sometimes we needed to fix a lot of bugs, and after our exploration, those bugs are will be resolved. Anyway, it's very cool to understand how to use cutting-edge technologies to improve our work and maybe make cooling services.
Yeah, no, I'm sure you've definitely inspired people. I think that's what sometimes the value of these sessions is. People don't know what they don't know in some senses. And so for you to be able to call out what these different things can do and why they differ, where they're better, is super valuable. I did want to tap on a slightly more difficult subject. Interestingly, you brought it in right at the end, the kind of responsible AI piece around this. It's always hits me, I think, when it's the voice piece and it sounded like you, and I was like, oh, what if you immediately think deep fakes, don't you? You immediately think people making you say things that you don't want to, that you wouldn't say, or something like that. How have you gone about learning about that space?
It's a crucial point, this one. When we cloned our voices, we reached a very high level, not the one that we showed, but very, very high. And so we understood that it's a powerful tool that could be dangerous in the wrong hands. So for this reason, when we are showing our achievement, we usually don't show the top of our results because it's something that from a low point of view should be defined. In a nutshell, Gianni and I, we can use the other voice without issues, and only a familiar can recognize the difference.
Yeah, no.
Yeah, and to add a little bit, how to learn about these topics. There are a lot of resources from Microsoft on Microsoft Learn to learn. And there are quite interesting resources, sessions, and documentation that, and also behind these services that you are either the commercial one or the open source one. Most of the times to set up all these things up and running, it requires a lot of time. So commercial one are behind maybe some regulation, some private wall that you have to form to compile to better understand the usage of the technology. For example, Microsoft text-to-speech voices are behind a request form that must be validated with the customers, but as well the other services. Instead, in open source, you must be responsible. And of course, it's complex to find additional models that are very high quality. That's the point. If you want, you can train yourself. You can build a data set and train yourself. It requires a lot of resources, but it's possible. So we need also to explain to other people how dangerous can be these technologies, but they can be used, of course, for the good and for the bad. But we need to explain how to use it in the proper way.
Yeah, no, great call out on that. Yeah, absolutely. Although sometimes the drop as a form to get access can seem frustrating when you want to try stuff out. Like, it is there as a monitoring technique in some senses, isn't it, to make sure that we do know what people are going to end up using this incredibly powerful technology for. I have one final one for you, which is I actually thought of it when you were doing, the really fast speech example that you had, and it sounds like a horse racing caller or something like that. I don't know, where you really can't understand like half the words that they're saying. The question was more about, obviously that was a generative AI approach that was able to then translate that really, really fast text in some senses from audio to text. I remember the first time I saw audio was the Stanford online Andrew Ng machine learning course, and he shows how you can like separate the two noises of someone counting in 1 to 10 in English and someone counting 1 to 10 in, like, I think it's in Spanish or something. What's changed? That's like, is it now better quality than that was in the past with more traditional approaches? Like, can you explain to the audience a little bit, what are the improvements that have been made there?
Yeah, related to Whisper, the one that we showed during the demo, it's a multi-language model. So it already supports 100 languages built in. And of course, you can pick the right model for your purposes. If you have options to use a large one, You can ingest the audio and you can transcribe in the supported languages. And also you can translate in English. It is a cool feature that if you have multiple languages, you can then translate to English. If you don't need all the multiple languages, you can pick a different, smaller model, so you can support just one of the languages.
But in any case, let me add that Whisper 2 and the last one, Whisper 3, is very, very good, not only from the performance and accuracy point of view, but the accuracy and precision, but also for the performance, because Generative AI was able to run translation in real time. To be honest, more fast than real time. If you ingest a record in a few seconds, can produce the text of minutes of text of a speech. It's a very, very advanced as a model.
And the most important thing is if you want, you can run it locally.
Yeah. No,
I have one question, and this one I'm asking for a friend. Are there also models that can help people learn how to play instruments, the violin, for instance?
Yes, exactly. But I say that for music generation is more than to teach people to learn instruments, is something that can inspire artists to create something new. Because writing a sentence, a theme, maybe can have a scratch of a melody, and then on top of that can build the composition. From usually, you know, about the generative AI, you listen always about ChatGPT, about maybe Deltatre and Stable Diffusion. Today, the goal, the Gianni AI, was to show how to use the same approach used for image generation or to text generation to generate music, voice, and ambiental audio.
Wow.
So also 10 years ago, we was able to generate music, but in this case, we are using the approaches introduced with image generation and text generation, and we are doing the same with approaches, different approaches, with great results.
Good.
Yeah.
So, do you think, does this help you in your journey?
I know. To let you in, I am the friend that she asked for. I recently, I'm looking to learn how to play the violin. I'm not really quite sure why. I've always wanted to do it for years. And obviously it will take quite a while, from what I understand, to like get a good tune out. So anything you were looking into where it maybe fixes the tinny sound that I might make at the start, you let me know. Keep in touch, and maybe I can impress people.
There is an interesting models that can separate audio between instruments. So if you want to practice violin with on existing music, you can separate the track and then play yourself the violin on other tracks.
That's interesting.
I do like that, because I said I was inspired by specific, like, you know, things in movies or things I'd seen on TV. So that's a really, really good idea.
Very good.
Thank you.
Maybe a model can catch a guitar solo and can translate it in a violin solo. Yes. So should be nice.
Yeah, you don't just do, you know, we don't just need code translating. We might need music translating. We might need words translating. That is a good, really, really good call out, actually. Anyway, we have kept you both far longer. Incredible talk. Thank you so much for sharing.
Yes.
I hope you don't mind us asking you a million questions, but it was really thought-provoking. So I appreciate your time.
Thanks a lot.
Thank
for the
you.
We're to Amber. Thank you all for the questions. And then if we want to, we can explore additional topics whenever you
feel free to reach us. We are very happy to share and help.
Incredible.
Thanks a lot.
Thanks very much. We'll speak to you later.
Bye-bye.
Bye-bye. Thank you.
Good afternoon.
Okay, so I think up next we have Sammy over on our student track. He's behind the scenes, so we're hoping we can kind of connect to him and maybe do a little check-in for a few minutes on what is happening over there. Sammy!
Hello!
Hello! How's it going?
How are you? Things are going quite well here. We've had some very interesting sessions. A student and a professor who worked together on a GPT application to to grade papers. So it's really interesting how they did that.
Very interesting.
By the way, have I told you already we have a Microsoft Garage here?
No. Tell us more about it. What is the garage?
Well, the garage is like, you could say it a garage where Microsoft employees can work on their own projects, but it's a combination of mechanical engineering linked to digital engineering. So bringing IoT devices, 3D printers, and so on. And then they have their like this, hard to arrow to it. The hackathon, the global hackathon that they do every year also. I'm sure, Amy, you can also tell more about that.
Yeah, the hackathon is brilliant. Once a year, a full week pretty much of, you can work with anyone across the whole planet at Microsoft on any project, doesn't have to relate to your work. And yeah, just like push the boundaries. And obviously each year those boundaries get pushed basically on people's passion as well as their technical expertise and their learning and all of that. So it's awesome to see that's there. I love the connection actually between the mechanical and like digital engineering and bringing the two together. I was saying to someone the other day, it was always my, you know, when like fashion started to dabble with like wearable tech and stuff like that. I don't think it's landed super well, unfortunately, but I was like, oh, that is where I would combine those two. But again, it shows like personal passion plus technology could create like a whole new genre, right, of things that you can do. So really, really cool to see that space. And so you are literally set up just next to this space?
Yeah, so here's the garage. And then we have a little bar over here. Oh, sorry, guys. There's a little bar, coffee bar. Of course, it's all closed today because 12 here. We're still recording.
Fantastic.
Okay, yeah.
Hello,
We're halfway
everyone.
the stream. We're looking at the session now about AI and creativity. Is also very interesting. So I would love to go back to that session and see what it's more about.
I know. We won't keep you too much longer. What else is coming up in the student track? How, like, anything of note?
I would need to look on the list now.
I know so many sessions.
You can see the whole list on the website. The whole track.
Yes, definitely.
Globalai.community/conference.
You said it first. Global AI.
/2.
So fantastic. Thank you so much, Sammy, for joining us, checking in with us. It's great to see you're having such a good time there. And also,
thank you later. Bye-bye.
All right.
Enjoy the rest of the day. Bye-bye.
Amazing.
So you also participate in those hackathons, those yearly hackathons?
Yeah. They give you a lot of warning, which is good, so that you can try and make sure that your calendar is like super quiet and like it's mostly like respected as well in some senses, that week is for people to go and try something new. It's also nice actually because you can work in groups of people that you maybe don't always work with, or other skill sets. Like I sit in a group that has like the majority just technical, passionate people that are really excited about, you know, talking about technology and learning and skilling. But actually working, say, with someone in engineering or a really cool PM or maybe someone from research even is a nice way to kind of see what other skills or opportunities are out there as well. It's great networking, which is nice.
Good,
so, yeah. But how about you? Did you get to do any things like that from your side of things?
No, not really hackathons. I'm not really involved in that. No, it's more community stuff, workshops that we publish, and
I was gonna say, hackathons have to be quite targeted. I always think like you have to ask quite specific questions or have something really specific in mind that you maybe have already started creating or you've kind of got somewhere with, so that, you know, by the end of the week you can kind of come out with something. However, with all of the generative AI stuff, you know, we called out that Imagine Cup advert. That's for students to go enter, but you can literally go with an MVP, a business case idea, create the technology, and then kind of be able to really take part in the competition to win some incredible prizes and basically become a startup. But the interesting part of that is kind of, we've just released some learn modules, they're called challenge modules, and they're literally ways that you can use generative AI to build a business case, create your logos, design your website, like all these different things. And it just shows like how quick you can get to that. So, you know, the key is you've got an idea. How you do it, hopefully the tooling can help you now.
Yeah, of course it can. We've seen lots of good models that can support you with that, right?
Well, even just the audio, right?
Yeah.
Like that was like practically an advert for whatever you would want it to be. It could be completely generated by a computer. So yeah, very interesting.
Exciting. So we still have some minutes to go before our next speaker. So we will go out for a little break and we will be back in 10 minutes.